Alright, let me do an example. And this is a little bit more complicated than the example I had before. The region is bounded by y equals x squared, which is this parabola, y equals x, which is this line. So this is the original coordinate system, x and y. We're going to rotate the region around x equal to -1, and when you rotate it, you get this volume. So let's do the method of cylinders. So I pick a vertical line in the region that we're interested in calculating the volume of. I rotate that line, I get a cylinder. Then R is the radius of that cylinder. H, this is the height of that cylinder, and I have to calculate h as a function of r. Now notice something. In contrast to the last example, both the top and the bottom points that define h change as I change r. So here h is this region, here it's this line, here h is this line. So both the top and the bottom are a function of r, and we have to be careful in figuring out exactly what h is. But the procedure is the same as before. We pick a point where the top part of the cylinder touches the region, and that's that. And we find out its coordinates in the axis of a rotation coordinate system. So the coordinates of that are r and this height. And that height, which is not the height of the cylinder, I'm going to call h2. So h2 is this entire height from here to here. So its coordinates are r comma h2. And in the original coordinate system, this is the rectangle, and I'm going to say that its coordinates are x2, y2. So this is x2, this whole thing is y2, and we can immediately write down the relations for this, and the relations are h2 is the same as y2, r is x2 plus this distance, which is 1, so r is x2 plus 1, and then because this point lies on y equals x, x2 equals y2. Okay, now let's do the same thing for the bottom point. So let's call this height h1, and in the rotational coordinate system, that's the rectangle. So this has coordinates, this is the x coordinate, this is the y coordinate, r comma h1. In the original coordinate system, let me draw this rectangle. This has coordinates x1 and y1. And we can again write down those relations. So let's see. Y1 is the same as h1. So h1 equals y1. R is again x2 plus 1. So r again is x2, it's x1 plus 1, because now we're doing the smaller rectangle. And x1, y1 lie on this curve, so y1 is x1 squared. Okay, so now we know how to relate h2 to r and h1 to r. The h that we're interested in, the height of the cylinder, actually is just h2 minus h1. h2 is this entire height, h1 is this height. So now we have a more complicated set of equations, but the idea is still the same. We want h as a function of r. So if we figure out how h2 is as a function of r, h1 is as a function of r, we can plug that in here and get h as a function of r. So let's try to do that. So here, h2 equals y2, y2 equals x2, and x2, if I move 1 to the other side, x2 is r minus 1. let's see, h1 equals y1. y1 is x1 squared. And again, if I move 1 to the other side, x1 is r minus 1. So this is r minus 1 squared. So this is h2, which is r minus 1 minus r minus 1 squared. Okay, I'm running out of space, so let me write this continue on a new sheet of paper. So v was 0 to 1, 2 pi r h dr, which we wrote as 2 pi 0 to 1 r h dr. And this was r minus 1 minus r minus 1 squared dr. And now we just have to do that integral. So let me just try to do it in a very simple way. R, and let me expand everything in here. R minus 1 minus r squared minus 2r plus 1 dr r minus 1 minus r squared plus 2r minus 1 dr. And let's see if we can simplify this. So r and 2r is 3r minus r squared minus 2. And if I multiply r with this, I get 3r squared minus r cubed minus 2r. So this is 0 to 1, 3r squared minus r cubed minus 2r dr. And that is r cubed minus r raised to 4 over 4 minus r squared evaluated from 0 to 1.